TON 618's central black hole is estimated at 66 billion suns, yet its light left when the universe was only about 3 billion years old. How could a black hole that massive already exist in the early universe? TON 618 is not seen as a black disk in space. It is seen as a quasar, a brilliant feeding system around a supermassive black hole. Gas falls inward, heats up, and outshines its host galaxy. Its redshift is about 2.22. Redshift is the stretching of light as the universe expands. At that redshift, the light has traveled for roughly 10.8 billion years. The mass is not measured by putting the black hole on a scale. It is inferred from gas close to it. One ultraviolet line from magnesium is broadened by gas moving at several thousand kilometers per second. The brightness estimates the size of the gas region. The line width estimates the gas speed. Together, those numbers give a virial mass, a gravity-based estimate. For TON 618, that estimate is about 66 billion solar masses. The uncertainty is large because the gas geometry and viewing angle are not known exactly. The age is the difficult part. A black hole grows by feeding, but feeding has a natural speed limit. At the Eddington-limit, radiation from the hot gas pushes outward as strongly as gravity pulls inward on surrounding ionized gas. With a typical efficiency, a black hole growing at that limit gains 1 I-fold of mass in about 45 million years. A 100 solar mass seed would need about 20 E-folds to reach TON 618's estimated mass. That is less than 3 billion years, but only with unusually steady growth. So the problem is not that TON 618 violates gravity. The problem is getting enough mass into one place early enough, without long interruptions. A heavier starting point would help. One proposed route is a direct collapse seed, formed when a large gas cloud collapses into a black hole of 10,000 to 1,000,000 solar masses. Another route is faster-than-Eddington feeding for limited periods. Mergers with other black holes could add more mass. None of these steps has been directly reconstructed for TON 618. TON 618 also does not prove that the mass estimate is exact. Virial estimates are powerful, but they are calibrated from other active galaxies, and a single quasar can sit off the average relation. If the gas is flattened, tilted, or disturbed, the inferred mass can shift. The safest claim is that TON 618 is an ultramassive black hole candidate, probably in the tens of billions of solar masses. The answer is that TON 618 can be this large if its growth history was extreme, not impossible. Its measured light points to a black hole of extraordinary mass, and the early universe allowed enough time only if the seed was large, the feeding was efficient, mergers helped, or the estimate is somewhat high. What remains open is the particular path. Better spectra, a clearer view of the host galaxy, and evidence of its environment would decide which growth route actually built it. That's why source. If this was worth your time, like it, share it, and tell me in the comments what you want examined next. If you would like to support this work, the Patreon link is in the description.